What's up, everybody? Welcome back to the weekly Wednesday live stream from Scalar Learning, all about SAT problems from the Khan Academy website. Let me do a quick sound check over here and make sure we are good to go. And it looks like we are. So, without further ado, linear and exponential growth. So make sure if you like these problems and you want to see more, subscribe to the channel. If you like this video, please click the like button. Find it helpful. It really helps the channel out a lot. And as always, I'm doing these problems for the first time, which is part of the fun. We're on linear and exponential growth, level 2. Sorry I had to do the late night live stream. Tried to do it this morning, just didn't have enough time before the day got started. Let's do it. All right, P equals A times 1 plus B to the KT. So this is definitely exponential growth because we got an exponential function and we've got that variable up top. Genetic mutation which adapts. You probably don't even need any of this, by the way. This is essentially to explain the equation, but it makes it harder in a lot of ways. I can skip this, but let's read it anyways. The population present with mutation P can be approximated using the equation where T is the time in years since the introduction of the mutation. A is a positive constant equal to the initial mutation population. B is a positive constant and K is a constant. Which of the following correctly explains why P would be exponentially or linearly increasing? Okay, so it's definitely, well, it's meant to increase, but okay, look. P is linearly increasing. We can pretty much discount this. If K is greater than 0, no. That doesn't mean, that would actually mean it's exponentially increasing. P is linearly increasing if A is greater than 1. Not really. That doesn't mean anything. It's still going to be an exponential function, whatever A is. P is exponentially increasing if K is greater than 0. Yeah. And this just basically means that K is a constant, right? So basically if it's positive, right? Or let's go the other route. If it's negative, okay, negative KT or something like that, really this would be like A times 1 over 1 plus B, whoops, to the T power. So then this would actually be decreasing. But if we know that this is positive, it's not like that, and it is going to be just a typical exponential function. It's going to increase, and it's going to increase exponentially. So I'm going with C. All right, cool. Question number 2. A statistician modeled the average private law school tuition in 2 ways. According to both models, 2011 tuition, 2011 was $40,000. In one model, tuition increased by both models, sorry, it was this way. In one model, it increased by $1,750 per year. In the other, the tuition increased by 5% per year. What would be the difference between these models in the year 2013? Okay, so 2013, clearly, this way is really easy, right? It's 2 years, so it's 2 times 1,750. This, you can use a calculator, but 2 times that is just 3,500. 3,500 plus that is 43,500. Now we probably use a calculator for the 5% because this is compound. Okay, let me show you what I mean. First, we take 5% of 40,000. Now that I can do in my head. That is 800. Wait, 8,000. Sorry, no, 3,200. I believe. Well, let's just do it anyways. 40,000 times 0.05 equals 2,000. Oh yeah, 2,000. What am I thinking? So 2,000. So after 1 year, it's 42,000. But we don't say, oh, it's 2,000 again and it's 44,000. Now we have to take 1.05 times 42,000. Why do I add the 1? People ask me this all the time when I'm trying to take 5%, because we're talking about a 5% increase. And I'm trying to find the final value. So that 1 ensures that what I'm going to get, I don't have to do an additional step. I'm going to get the final amount that it will cost in 2013, which is 44,100. So that's called compounding the percentage increase. It's like first we get 5% of this, which takes us to 42,000. But then we take 5% not of 40,000 again, 5% of 42,000 again, which is actually 2,100, and that gives us this. So what's the difference between those two? It's 600. Okay. An accountant is modeling the annual tax expenditures E in thousands of dollars T years after January 1st. Okay. So that's tax expenditures T years. All right. For a small business using two different models, both of the accountant's models have tax expenditures of 5,000, so 5,000 on January 1st, 2000. Okay. Model 1 has tax expenditures which increase which increase by 4,000 every year. Okay. Model 2's expenditures which increase by a factor of A every 5 years. Okay. So A over 5, I guess. If the models have the same value on January 1st, 2010, okay, let's forget that. Okay, so basically on January 2010, what's the value of A? Well, every year, the first model, it goes up by 4,000. So in 2010, that is 10 years. So we can say that that's gone up 10 times 4,000, which is 40,000. So tax expenditures by one model would be 45,000. Okay, but this other one, it's increasing by a factor of A every 5 years. And in this case, that's twice, right? So essentially, we're going A times A 2 times 5,000 has to equal 45,000. That's it. Solve this equation. That's A squared times 5,000 equals 45,000, right? So once again, I had to do two A's because it's every 5 years. And how many times does that happen in 10 years? Twice. So now we'll divide both sides by 5,000. Divide both sides by 5,000. We get A squared equals 9. Therefore, A equals the square root of 9, which is 3. Should be correct. It's correct. All right, question 4. No multiple choice for some reason. Or only one in the beginning. For the last decade, the number of insured children who had dental cleanings has been growing by 5% per year, or by about 68 children per year, depending on how the growth is modeled. This year, 1,760 insured children had dental cleanings. To the nearest whole number, what is the difference between the numbers of children that the models predict will have dental cleanings 3 years from now? Okay. Well, this way, it's just 3 times 68, right? So that's 180 plus 24 is 204 plus 1760 equals 1964 by one model. And the other one is 5%, right? So it's 5% each year for 3 years. So the simple way to do this is in a calculator, 1.05 to the third power times 1760. Okay? If you don't want to do it like that, you can just be like 1.05 times 1760, get your answer, multiply by 1.05 again, get that answer, multiply that by 1.05 again. I'm trying to save some time here. So it's basically 1.05 times 1.05 times 1.05 times 1760. So let's put it in here. $17.60 equals 2037.42. 2037.42. And now I'm going to subtract 1964 from that. And that equals 73.42. Nearest whole number, round it to 73, I guess. Let's see if that's right. That's right. Another one of these. Free response, last but not least. 1945 to 2008, countries per capita gross domestic product increased by about 6% per year, ending at that. Okay. Wow, that is a long time. 550, 63 years. 63 years. Just write that down just in case. For the next few years, we don't need this. For the next few years, the growth has slowed to an increase of about 1,300 per year. To the nearest dollar, how much less did this grow during the next 6 years than it would have grown if it had maintained the earlier growth rate? All right, so we're at 19,600. 6 years times that, right? 6 years times 1,300, that's 7,800. You can use a calculator. I'm just doing it this way because I think it'll be faster than clicking back and forth. We're adding this. 14, carry the 1, 16, 17, carry the 1, 2. So 27,400, all right? That's how much it's growing at this rate. Now let's calculate this. So what did I say? Once again, if the number of years, we know that interest rate, we just raise it to the number of years, which is 6, multiplied by this guy, right? By our starting point, 19,600. (1.06 to the 6th power, once again, number of years, times 19,600, 27,802, 27,802.98, I think it is, right? 97. To the nearest dollar, how much less? So now we got to subtract 27,400. And you can see that we're probably right because these are close together, the numbers. It feels right. It feels good. And so I'm confident about that answer. And so how much less to the nearest dollar? So I'm going to round it up to 403, right? Boom. There you go. So that is it for our Wednesday weekly live stream. Again, sorry that this had to start so late at night. I wanted to do it in the morning so you could check it during the day, but hopefully you're still going to be able to check it out and learn from it. Like I said, if you want to see more of these Khan Academy SAT problems solved on the regular, subscribe to the channel. Also, if you like the video, please click like. And if you have questions on how I solve these problems, please leave those questions in the comments below and I'll get back to you right away. Thank you guys so much for joining, and I'll see you guys next time. Take it easy.